Hello, today we will solve together an extra problem on free fall. Okay. So a ball is thrown from the top of a building with an initial velocity of 20 meters per second straight upward. Okay. So the initial is 20 meters per second at an initial height of 50 meters from the ground. So h is 50 meters from the ground. Okay, these two pieces of information are already on the plot, on the graph. The ball, sorry, on the figure. The ball just misses the edge of the roof on its way down. This is just to say that when it went up on its way down, it didn't reach the roof. It went down to the ground. Okay. Before I start solving this type of problem, whenever I see free fall problem, we agreed that we put on it all the information we know. So we start at the origin. What do we know at the origin? We know that the position is 0, and we know that the initial is 20 meters per second. This is what he gave me. This is given. Okay? This is from the initial position. I know also that at the maximum position, the x will be x maximum and the velocity will be 0. Okay, this is also a piece of information I know. What else do I know? I know that just before it reached the ground, xb is minus h, in this case is minus 50, and vb equal v maximum. So I put these three pieces of information on my figure, and never to forget that acceleration is minus gravity. We take it 10 meters per second square. If he doesn't say how much is it, just take it 10 meters per second square. Okay, in the exam, it will also be 10 meters per second square. So these are all the pieces of information I know. Now I can start trying to solve my problem. Okay, we will do it together. So calculate the time needed for the ball to reach its maximum height. So this is from where to where? This is the time needed for the ball to reach its maximum height. This is from where to where? This is from O to A. Okay. What do I know from O to A? Do I know V initial, which is VO? Do I know V final, which is VOA? Do I know acceleration? Do I know delta X from O to A? And do I know delta T from O to A? Let's see. I know V initial, it's 20. I know V maximum, it's 0. I know the acceleration, and it's asking me to calculate delta T. Okay, so I come to my equations. Which equation has V initial, V final, acceleration, and delta T? It's this equation, equation number 3. So I will use equation number 3 to get delta T from O to A. Okay. Part B, calculate the maximum height with respect to the roof. So I want to calculate what? I want to calculate delta X from where to where? From O to A. Can I calculate it? This is delta X from O to A. I just go back here to part A. Now I have VO, I have VA, I have acceleration, and I have delta T. So which equation will let me get delta X? Actually, any equation. The first one I can use, the second one I use. The third one I cannot use because there is no delta X. And the last one I can use. I like the last one, so use equation 4. This way I get delta X from O to A. Okay. Part C. Calculate the time needed for the ball to return to the height from which it was thrown from. Okay, Actually, here there are two parts. So first we need to get the time. And then we have to get the velocity, okay? For the ball, when it goes up and then comes back to the initial position, okay? So it is this position over here. Over here. Okay. Okay. So what do I know? What information I know? So here I'm going from where to where? I'm going from O to O. Okay. Do I know VO? Do I know V final as it's going down? Let's call it VO prime. Do I know the acceleration? Delta X from O to O, delta T from O to O. Okay. Let's see, what do I know? I know VO, it's 20. It's the velocity I give it. I know VO. VO prime, I don't know it. I don't know how much is the speed when it was going down. Acceleration, I know it. It's -10. Do I know delta X from O to O? Do I know delta X from O to O? Yes, I know that it is 0. So I also know this, but what I don't know is delta T. I don't know delta T, I don't know VO prime, and these are the two things he's asking me about. So let's start with the time. Which equation? So I have V initial, I have acceleration, I have V initial, I have acceleration, I have delta X, and I want delta T. For this, let's look at the first equation. Delta X I have, the initial I have, delta T I want it, and acceleration I know it. So the first equation will make me solve for delta T. Equation 1 for delta T. And then I want to get the velocity. So after I get delta T, I want to get the velocity. Notice that now I can use, for example, the second equation because I want V final. I have the initial, I have the acceleration, and I have delta X. Okay, so I can use the second equation, or I can use the third equation because I have the initial, I have acceleration, and I have just calculated delta T. So I can use also the third equation. I can also use the fourth equation, by the way. So equation 1, sorry, 1, no, 2, 3, and 4. Any one of them will be okay. Then part D, calculate the time for the ball to reach the ground. So I want the time for the ball to reach the ground. So it's from where to where? To reach the ground, it's delta T from O to B. Okay, what information do I know? Do I know VO, VB, acceleration, delta X from O to B, delta T from O to B? Let's see, what do we have? I have VO, it's given. I don't have VB. I don't have VB. I have the acceleration. I have delta X, it's -50. And I want to calculate delta T. Okay, so which equation I can use here to get delta T? Again, I have to use the first equation because it has delta X, it has the initial, it has acceleration, and my unknown is delta T. So here I have to use equation 1. Just note here that you will have to learn how to use quadratic equation, how to solve quadratic equations using scientific calculators. Okay. Okay. Part E, calculate the velocity and the position of the ball at t equal 5 seconds. So here you have to imagine that it's somewhere. I don't know where is it. I don't know where is it. Let's assume it's here. And let's draw it in another color. So just assume it's somewhere here. Name it C. Name it C. And you have to calculate the velocity and the position of the ball at point C, which is 5 seconds. So he's giving me delta T here, okay? You have to calculate VC and BC, XC, BC, and this part, I leave it for you to try on your own, okay? And in tomorrow's live session, I will be going again through this exercise and we will do this last part together. So as you can make sure you solved it correctly or not. Okay, so all answers are found in the following slide. So undo here, or you find all the solutions here, okay, here and here. They are all solved except for part E. We will solve it together tomorrow during the live session. Okay, that's it for today and see you tomorrow.